In 1958, scientists put a vision that we need to fly a spacecraft within the atmosphere of the sun. But it is so challenging, extremely difficult to realize, that it took us 6 decades to build a system that can fly safely and reliably within the atmosphere of a star.
3, 2, 1, 0. Liftoff of the mighty Delta IV Heavy rocket with NASA's Parker Solar Probe, a daring mission to shed light on the mysteries of our closest star, the Sun.
It looked like we had a hit there for a second.
Yes, Nick. I believe we do have a detection of beacon tone 1.
There it is. See it? There it is.
Parker Solar Probe is
3.8 million miles from the surface of the sun.
It is so incredible to just realize this is the moment that we designed this mission for. 3.8 million miles may not sound that close, but if I put the sun and the Earth 1 meter apart, Parker Solar Probe would be 4 centimeters from the sun. It's the closest human-made object to a star and also the fastest, traveling at 430,000 miles an hour. I mean, we're flying through the atmosphere of a star. That's not easy to do. It's something we've never done before.
This is our first close encounter with a star, and it's really just amazing. This area that Parker is going into is just so crucial to our understanding of the sun and its impact on the Earth.
That solar interaction, that space weather, those billions of tons of material that the sun can throw at us, interacts with our power grids, can interact with our technology. So it's really important to understand them at their source and how they get all that energy.
When we were thinking about designing a spacecraft to go to some place that had never been before, and it's actually going there to study the sun, and so you're kind of saying, what am I designing? What are the environments it's designing for?
It has to go from the deepest, coldest space to a very warm area and keep everything working at a little bit above room temperature.
It's designed to go to such an extreme environment. You look at it and it doesn't quite look like most other spacecraft. The whole thing is designed such that the heat shield is taking most of the brunt of the heat of the sun. The heat shield will be at about 1,800 degrees Fahrenheit, and it's protecting the spacecraft. So the spacecraft's actually basically at room temperature.
This is such a great feat of engineering, and it really shows how capable we are in space.
This is something that we've been wanting to do since 1958 when it was first mentioned, and the technical problems that had to be overcome in order to achieve it is just monumental to be able to get a spacecraft this close to the sun.
To get close to the sun is not easy. It looks like from Earth to the sun, not that far. The key issue is energy. In order for Parker to get close to the sun, we needed to lose a lot of Parker's speed possessed at Earth's orbit. Fortunately, I was able to create a trajectory with 7 Venus flyby.
The mission uses Venus in order to actually change its angular momentum and slow down to actually go closer and closer to the sun.
Over the course of about 6 years and the 7 flybys, we were able to move closer to the sun, and each time unraveling a little bit more of the mysteries of the sun as we get data from places that no spacecraft has ever been before.
It's the only star in our galaxy that we can actually go visit, and that's what makes it so magical.
By flying within the atmosphere of the sun, we are basically tracing the fingerprints of the physical mechanisms of the sun. We now view the sun in a different way. When you look at images from Parker Solar Probe, oh my goodness, they are extremely, extremely complex. And that complexity, for us, it's a new science that we need to investigate, we need to understand.
The things that we've learned over the years that Parker has been in orbit have been amazing. They've challenged our ideas about how the solar wind is made, about how the sun works, about some of these fundamental things that are going on.
There's a lot of pride and excitement. for this closest approach. So much effort and so many people have worked on this.
I think it really took the teamwork and synergy of engineers and scientists and administrators and a lot of different people to think this mission up.
It makes you think that you can basically overcome any hurdles. So dream big and go out there and make them happen.